Hi all, I am Chitra Lekha from the Department of Artificial Intelligence and Data Science from SA Engineering College. Today in GATE coaching session, I am going to talk about what is hierarchical clustering. It is a part of machine learning techniques. First I'll tell you what are the topics I have covered in this GATE coaching session. First one is what is machine learning. Second one is the types of machine learning. Third comes what is supervised learning, then the unsupervised, and finally the topic what we have chosen is hierarchical clustering. We will see one by one what is machine learning and the types. Okay. Machine learning is basically like we have to train a machine model through the AI concept. That is the concept of the entire machine learning. Okay. The definition of machine learning is that machine learning is a field of artificial intelligence that allow computer to learn from the data and improve their performance without being explicitly programmed. Okay, a machine will be trained based on the AIs and the algorithms what we have been giving to the machines. Machine learning algorithms are trained on large data sets. Machine learning is basically for large data sets, allowing them to identify the patterns and makes the predictions or decision based on those patterns. Whatever pattern or data set we are giving, based on the data sets and patterns only, we are going to predict the result. Next comes the types. In machine learning, it is classified majorly into supervised learning and unsupervised learning. Supervised learning is further classified into regressions and classifications, and unsupervised is classified into clustering. The major thing is clustering and one more is associations. We'll see what is supervised and what is unsupervised learning. Supervised learning, the name itself say it has a labeled data sets. Supervised learning always follows a labeled data sets, and as unsupervised learning name defines that it follows an unlabeled data sets. We will see what is supervised learning as a proper definition. Supervised learning is a machine learning techniques that uses labeled data sets to train the artificial intelligence algorithm models to identify the underlying patterns and relationship between the input features and output features. Based on the labeled data sets only, we are going to train the machine learning model based on the artificial algorithms through their patterns and relationship between the input and output features. Supervised machine learning helps organization to solve for various real-world problems at a scale such as classifying the spams or predicting the stock prices. Especially supervised learning is used in real world example, majorly in spam classification and predicting the stock prices. The workflow of supervised learning is labeled data. So we already give some labeled data. Those labels are given here. Okay, whatever here I have explained with the shapes, different types of shapes here, and I have given their labels here. I am using hexagon, triangle and square. Those are given through the training models. These models will train the labeled data and it gives some predictions based on the test data. My data is tested here based on the labeled data sets, and further more predictions will be done through the trained model, and the trained model will give me what data I want. Like here I am getting squares and triangles. So this is the workflow of a supervised learning model. Next, supervised machine learning is further classified into regressions and classifications. Now we are going to see what is unsupervised learning. Okay. So what is unsupervised learning? Unsupervised learning is a machine learning technique where algorithms learns from unlabeled data. As I have previously said, supervised learning is labeled data sets and unsupervised learning is full of unlabeled data sets. It don't have any name, that is unlabeled. Unsupervised learning is helpful for finding useful insights from the data. Unsupervised learning is much similar to a human learns to think by their own experience. In supervised learning, based on the labels, the data have been processed and the patterns have been recognized. In unsupervised learning, it is more similar to a human learning and thinking of their own experience, okay, which makes it closer to the real AI. Unsupervised learning works on unlabeled data and uncategorized data. That is unsupervised learning. In real world, we do not always have a input data with the corresponding output. To solve such cases, we need an unsupervised learning. The workflow of unsupervised learning is, it is a raw input, we don't give any label here. As in supervised learning, we just given the labels to the pictures what I have represented. Here I just given the raw data. The raw data has been interpreted through the algorithms what I am going to use. Here I am going to use hierarchical clustering. Based on the algorithm, it is been processed, and what output I need, it will be categorize the output based on its label and it will give it to me. This is the workflow of an unsupervised learning. Next comes the types of unsupervised learning. It is classified into clustering and association. We are going to see what is clustering. Clustering means grouping up of some data. So the proper definition is, clustering is a method of grouping the objects into some clusters such that the object with most similarities remains into a group and has less or no similarities with the objects of another group, which has a more similar similarities, means it will be grouped together. Some will be having less similarities or no similarities. That category of data will be clustered into another group. Cluster always finds the commonalities between the data objects and categorize them as per the presence and absence of the commonalities. Next is the hierarchical clustering. Hierarchical clustering is an unsupervised machine learning algorithm which is used to group the unlabeled data sets into a cluster and also known as hierarchical cluster analysis. In hierarchical clustering, we are going to process the data, that is, we are going to process the unlabeled data through the clustering techniques. It is represented or called as hierarchical cluster analysis. In this algorithm, we develop the hierarchy of a cluster in the form of trees. In the form of tree structure only we are going to process the hierarchical clustering. What is hierarchical means? A node followed by its child nodes, that is known as hierarchical. That is, one followed by the other will be represented in hierarchical format. So based on the tree structure only we are going to process the hierarchical clustering data. This tree shaped structure is known as the dendrogram. Here in hierarchical clustering, the tree shaped structure is called as dendrogram. Here we follow two approaches in hierarchical clustering. The first one is agglomerative, second one is divisive. We are going to see what is agglomerative and what is divisive. Agglomerative is a bottom-up approach and divisive is a top-down approach. The reverse of agglomerative is divisive approach. We see in detail what is agglomerative hierarchical clustering. The agglomerative hierarchical clustering algorithm is a popular example of hierarchical cluster analysis. To group the data sets into the cluster, it follows a bottom-up approach. That is, it follows a bottom-up approach, which means that from a single data, it processes up the further data and it groups up into a cluster. That is agglomerative hierarchical clustering. It means that this algorithm considers each data as a single cluster. Each data as a single cluster. At the beginning itself, it will consider every data as a single cluster, and then it starts combining the closest pair of clusters together. This is the process of agglomerative hierarchical clustering. It will find the individual data first, individual cluster first, and then it groups up with the nearby clusters and it forms a hierarchical clustering. It does this until all the clusters are merged into a single cluster that contains all the data sets. This is agglomerative hierarchical clustering. This is the first step. I have represented through a graph. Let's see. Create each data point as a single cluster as we have defined already. Let's say there are n data points in this graph. So the number of clusters will also be n. How many data we are giving, that number of clusters will be processed. So consider the x-axis and y-axis. I have given n number of data points here. This is the first step. Next step, take the two closest data point or clusters and merge them to form one cluster. As we have seen in the definition of agglomerative clustering, the single data, it follows a bottom-up approach. So the single data are grouped together. How it is grouped means the closest data points are grouped into a single cluster. So here these two data are closer, so these two forms a cluster. This is the second step. In third step, it will search for any other closest pair, and here it is, these two will be closer enough, so it forms a cluster here. These are similar types, so it follows a cluster. Next, repeat the step 3, that is until only one cluster is left, we will get the following clusters. Okay, we'll again club which all are nearby. So those data points are clubbed together in the fourth step, and once the single data is left, it will be clubbed to the entire cluster format. Okay. Once all the clusters are combined into one big cluster, develop a dendrogram. This is how a dendrogram will be developed. Through this graph, we are going to develop a dendrogram. After the entire clusters takes place, we are going to implement it through the dendrogram concept. We will see what is dendrogram. This is the working of dendrogram in hierarchical clustering. The dendrogram is a tree-like structure as we have already said, that is mainly used to store each step of memories that the hierarchical clustering algorithms perform. In this dendrogram plot, we have the y-axis to show the Euclidean distance between the data points and the x-axis to show the data points of the given data set. The working of the dendrogram can be explained through this diagram and the steps followed by the diagrams. Okay. Here I have given P1, P2, P3, and here I have given the data sets or data points as P4, P5 and P6. As seeing the diagram itself, we can see P1, P3 and P2 are closer, so it forms a cluster here, and P5 and P6 are closer, so it forms a cluster here. It forms a group of two data points as a cluster. Then it searches for the next nearby data point. So here the next nearby data point is P1, so it forms an entire cluster here. Then here it is P4 and it forms an entire cluster here. Then once the points have been clustered, it will form another whole cluster, that is making all the points from P1 to P6, it forms an entire cluster. This is represented through dendrogram as the y-axis represents the Euclidean distance and the x-axis represents the data sets. So firstly, what we are clubbing or clustering, P2 and P3. So it has been clustered as in rectangular format. Then we are processing P5 and P6. Next nearby thing is P5 and P6 data. So we are clustering P5 and P6 as a rectangle. Then we are going to club 3 points together. Firstly we club 2 points and now we are going to club 3 points together. So we are going to club P1, P2 and P3. So I am forming another cluster which is represented as a rectangle in dendrogram. Similarly P5, P6 and P4. So P4, P5, P6 will be represented as a rectangle in dendrogram diagram. Then we are going to form the whole cluster. So from P1 to P6 we are forming a whole cluster. This is the diagrammatical representation of a dendrogram in hierarchical clustering. So this is the explanation of the diagram. Okay. As we have discussed above, firstly the data point P2 and P3 combine together to form a cluster. Correspondingly a dendrogram is created which connects P2 and P3 with the rectangular shape. See, firstly we have connected P2 and P3 as a cluster, and in dendrogram diagram we have represented P2 and P3 cluster in a rectangular shape. The height is decided according to the Euclidean distance. Euclidean distance is given in the y-axis. Based on the Euclidean distance only, the cluster's height is being declared or defined. In the next step, P5 and P6 form a cluster and the corresponding dendrogram is created. It is higher than the previous as the Euclidean distance between P5 and P6 is little bit greater than P2 and P3. When comparing P2 and P3 distance, P5 and P6 distance are little bit higher. So the rectangle's distance or width will be varying. Again, the two new dendrograms are created. Then we combine P1, P2 and P3 in one dendrogram and P4, P5 and P6 in another dendrogram. And finally, we create the entire dendrogram in agglomerative hierarchical clustering. Next is divisive clustering. Divisive clustering is an hierarchical clustering method which involves in dividing every cluster into small subsets. That is, it follows a top-down approach. So the huge data is being divided into smaller subsets and then it is being processed in hierarchical clustering. So now we are going to see some of the questions related to hierarchical clustering. The first one is, which algorithm is used for hierarchical clustering? First one is k-means clustering, second one is agglomerative clustering, third one is DB-scan, and fourth one is principal component analysis. As we have discussed agglomerative clustering, in hierarchical clustering we just follow the agglomerative clustering. So the answer will be agglomerative clustering. Second question. What is the primary purpose of decision trees leaf node? The decision trees leaf nodes primary purpose is what? So first option is to make predictions, second one is to split the data, third one is to represent the feature, and fourth one is to store the feature. The purpose of tree is always to predict the data sets given to the tree structure. So the answer will be to make the prediction is the right answer for the primary purpose of decision tree leaf nodes. Third question. Which machine learning approach is based on the assumption that similar data points are more likely to have the same labels? The options are clustering, classification, regression, and anomaly detection. So in clustering only we just follow the similar data types grouping and also the non-similar data types grouping. So the answer will be clustering. Next question. In agglomerative hierarchical clustering, single linkage means that the distance between two clusters is defined as the maximum distance between any 2 points in the cluster or the minimum distance between any 2 points in the cluster, the average distance between all pairs of points, the distance between their centroids. In agglomerative clustering, what we have seen is bottom-up approach, that is from single data only we are going to group up the entire cluster. So the nearby nodes only grouped together. So the options will be, the answer will be the minimum distance between any 2 points. So which has the minimum distance, that will be paired up first or clustered first. The last question is, if we cut a dendrogram at a particular height, we obtain a single cluster, a flat clustering K cluster depending on the cut, a non-hierarchical grouping with the random partition, or the same clustering as a mean. As in dendrogram diagram, we just follow a graph structure which will be in a rectangular formats, right? So when we cut the dendrogram, we just get the flat surface. I'll tell with an example or the diagram. See, this is the dendrogram diagram. Once we cut the dendrogram, we just get the flat surface. The blue line indicates the cutting of a dendrogram. Here we just get the flat surface. A flat clustering with clay cluster depending on the cut. The remaining topics, that is the part of agglomerative clustering or hierarchical clustering, will be continued in the next GATE video session. Thank you.